Welcome. I'm very excited to share with you this DIY project I've been working on over the past few weeks. It is a USB HID/PID flight simulator hardware interface. If you're not familiar with HID or PID, HID is a human interface device, and it allows you to connect to your PC or computer, and it automatically maps certain functionality for like buttons in a flight controller or a joystick without having to install drivers. Similarly, the PID is for physical interface device that allows you to do the same thing by getting information back from like a flight simulator to like a force feedback from the cockpit in a flight simulator. So with that, I'll go over the introduction to building this DIY project, which is again a USB HID PID flight simulator hardware interface. And this is for Avionics /PFD, MFD, or other systems within your flight cockpit in the simulator. And this is done with the STM32H723ZGT6 Arm Cortex-M microcontroller. So this is a very small board and it comes with that microprocessor. So if you wanted to develop, this is a good way to test out the features and the functionality. On this microcontroller development board, it is based on the STM32H723 board, and it's on Amazon, and it is only for $20. And I'm going to show you what it looks like a little bit more, but for right now, you can check out the Amazon link for $20. This is a very good introduction, and it is by EC Buying. I've been very impressed for $20, the functionality and the features behind this board. So give your feedback and tell me what you think about this board. Moving on. So I'm just going to go over main key features that are highlighted. 555 megahertz, which is very powerful for a microcontroller. The onboard crystal oscillator for this is at 25 megahertz. It also includes a 32.768 kilohertz for low speed. And for other oscillators, it has the 64 megahertz. For our interest, we're going to use for full speed USB. It has the 48 megahertz HSI on board. It can operate from 1.62 volts up to 3.6 volts. It has an analog ADC, so it has two 16-bit ADC. It also has a 12-bit ADC analog to digital conversion. And then for the USB 2.0, it's a full speed or high speed mode in device, host, or OTG controller, and with a dedicated DMA. So it's a really nice board. It has 144 pins and up to 114 I/O ports with interrupt capability. We're using interrupts for button operations, so that's something we'll go over more. I'll go more over the schematics, a little bit more on the programming HID descriptor I made for it. And we'll go over a few different features on this. So apart from that, it has 4 DMA controllers, 24 timers, and this is the very important part of what we're using, because we have 7 encoders, which are based upon 4 knobs, encoder knobs we have. This is using the quadrature incremental encoder input setup that I will go over in the next upcoming videos to show you how I got to work. Currently, I have 14 buttons that I map. I can expand to a lot more buttons on this, but all these I have currently using have the functionality for interrupt, and I'll show you how I got the interrupt working on this board. But I'll go over some more details for you with this. But for now, this is very interesting, and I want to share some more with you. On the ST website, you can go into more details about this board. You can see that this is a high performance with DSP functionality. Again, some of the features that we went over, but you can get a lot more information on the board here. Yeah, I wanted to focus on the features that I was using in the development process, but there's so many functionality. And that's one of the reasons I got this board, because I intend to continue to improve this project, to add different functionality with force feedback, with probably displaying like cockpit information on LCD. And if you look at this, the images to the right, there's so much functionality with this board that I wanted to use this one, because I know it's way more than what you need, but it allow us to add as much buttons and functionalities as you want, well, from the flight simulator. So you can use the buttons On the avionics systems, you can also add additional features from other inputs or outputs you want from the cockpit. So let's go ahead and dive into some more information. So this is a specification sheet for the STM32H723 microprocessors, and these also just go over a lot more of the features, and you will love this. I'm telling you, it has 4 DMA controllers, so many features that you would love. So take a look at it. The links are provided to all these from Amazon links as well. So let me know what you think. And more importantly, I want you to look at this from your view and tell me how interesting it is. I know it is for me. All right, so let's move on. Here's the fun part. I call this the ugly duckling. This is my custom development board. And of course, with this, you're definitely well, it's not the most presentable board, but I manually sorted it on a breadboard, and I added the risers so I could attach, because I wanted the functionality on this board to be very customizable. So if you can see different wires that are pinned in the middle section, and that allows me to go ahead and reassign buttons. So if I wanted to reassign certain buttons, certain features, I could. So that is it for this board. I'll go over more with it later. So this is a custom prototype expansion board view 2, where you can also see the different features. So this is SimpleHIDWrite. It's a utility that shows you the data coming in and out. So if I was to turn the knobs, you can definitely see, actually, this I have to reset. Sometimes it gives you a little trouble. So as you increment, as you turn the encoder up, it will give you the lower bit. So there's 16 bits that control the 7 encoder. So 2 extra bits are not being used right now, but it's for further implementation of a second encoder if I need it. But at least for right now, you can see the buttons. So if I turn the encoder down, the second bit will light as a button. And in the cockpit, I'll show you how I map these. And if I turn it up, the lower bit will map. So each encoder channel is mapped to a pair of bits. So the second encoder on the lower knob, it actually, when you turn it down, it shows the upper bit. And when you go up, it shows the lower bit. So each encoder is also attached to 2 pins. And you can see in the screen also the USB, the SimpleHID, the values of is being triggered. So as you see also, when I turn each encoder, if you look, you can see the values changing. I am not using that currently, but in the future, I wanted to include those values, because the encoder, the clock is set to count up to 255, and I could map that to some other feature if I was to write a custom driver, or maybe if I could map in the simulator to use it. But for right now, I wanted to include it so for future use. So yep. So as I turn the knobs, you can see the appropriate encoder values changing, and you can see the buttons. So if I'm pressing each button, you'll see it corresponds to the bit or the button going over on the utility. This utility that is lighting up, that comes with Windows. So if you just search Windows for your game controller or just game, you will see this utility pop up for you to set up your joystick. So yeah, so that's what I'm using currently. And these encoders, as I said, will map to the flight simulator. So we'll discuss that a little bit later. So the next thing I wanted to go over, what was the initial motivation? Well, it was the right side MFD. When I was flying in the flight simulator, I wanted some way to access the navigation interface on the G1000 without using a mouse. So it was desire for physical avionics contact when navigating in a simulator. I'd done some flight training before, so I'm a student pilot, but I've not resumed my training yet. It's been a while. But yep, I just finished my aerospace engineering degree, and I'm starting my grad school in aerospace engineering. So I have to get priorities for that. But with the desire for physical avionics contact when navigating, that was one of the main factors. And then avoiding being distracted with a mouse use in the cockpit. I don't know if you've flown in a simulator, but it's not fun trying to change your view to get over to a knob that you can barely see in a cockpit. So that was the motivation. So yeah, and to enjoy a more realistic experience. I know I said initially it was the motivation for the right side MFD, but this can be applied to beyond the MFD right side. Therefore, the aim for this project is to extend the development to HID interface beyond the Avionics PFD MFD use, and include like force feedback and other functionality from a simulator. So that's something I will be working on. So this will be an ongoing set of videos that will go over as I make improvements. So ultimately, this will morph into also a physical design. So if you look to the right, you'll see the G1000 interface, at least the right side of it. So I will actually design the hardware to look more like that for different instruments within the airplane. I'll use SolidWorks to do the CAD and then probably 3D print for prototypes to get more into it. So that's the vision further down the road. This allows me to be able to swap it out with different boards if I wanted to, or to make changes. In the SimpleHIDWrite Utility, you can see if you look at the right, it goes the right data channel. It actually it controls that value, the potentiometer from 0 to 255, or from X00 all the way up to XFF. So there it is. So that will also control like an axis if I want. So I could use that or add even more knobs. That one is a 100K variable resistor I'm using. What's also cool is I can also control output data, meaning I can send information from the computer back to the board. As I said, there will be more videos that will cover the design, configuration, coding, circuit, and other considerations that I needed to use to implement this. The article that I used as a reference was this. It was done by B. Montanari, and he's an ST employee. And he actually wrote this article that covered the basic implementation of the custom HID class with the STM32 boards. He was using a very smaller microcontroller board. It's the 32F0 series, and those are very light but very functional. And so I followed his article just to give me a baseline of what I needed to use on the STM32 boards. And from there, I went ahead and designed my implementation of it. So I'm loading up the flight simulator with destination, well, the departure location to be in the Baskerville or Ian Fleming International Airport in Jamaica. And that's where I will start from. Well, I'm not going to fly right now, but at least show you what I'm doing to map. So it should do that. So let's go ahead and make some changes here. All right, now that we are in the cockpit, there are a few buttons that are actually already configured. And if you can see here, if you look at the frequency in the top right of the COM frequency, you can see the values changing. The lower knob, lower part of the knob, again, this is encoder 1, first channel, and the second channel of the encoder. So if the base I'm using to control the frequency, the decimal portion, and the top part is the decimal portion. And as you can see, that is controlling the value there. And if you look at the buttons being pressed on the screen, so as I turn the top portion, 2 increments the value, and as I turn to increase the 1 bit, so each encoder is 2 bits, right? So so for this encoder is 1 and 2, and for the second encoder it's 3 and 4. So when encoder, second encoder controls the frequency in increments of 1 megahertz. So I'm lowering it right now. Let's go to 121. All right, so that's being mapped to that. So that's how I got that to work, was to map it to the increment and decrement values, or to increase and decrease the values. So for right now, let's go ahead and start the setup. So let's look at the MFD, the menu. I think the menu is what we wanted to push, the push button. So let's try the push button this time, and we're going to use 25. Oh, yeah, I have to select the device that I want. Yes. So push button. So 25. So 25 should work on that. So let's test that out first and see. So now that I'm here, so if I hit that button, yeah, there it is. Oh, it pops up that menu automatically now. So if I'm in the cockpit and I want to hit the menu button, I can hit it and it will come up. So hitting the menu. So now we can do the direct to. So if I go to the direct to, let's do the direct to. So correct, this is the one, yes. So let's go here, and I want to MFD direct to button push. So perfect. So if I do this, sorry, let's do this. Yeah, so let's try this again. Sorry, that was my fault. So the direct to. Okay. So yes, so the FPL, let's do the FPL. Yeah, I had to take some time to think how I wanted to approach this. There's a push button, button push, the FNS upper knob push button. So if I scan this and I'll push that, that assigns that button to that. But I want the lower knob increase, and then there's an upper knob. Okay, so the lower knob decrease and the lower knob increase. So let's do the increase first. So, and then the decrease. Actually, no. Okay, that's it. And so we're going to do the upper knob increase, and upper knob, oh sorry, it's the other way around. So the decrease, let's delete this assignment here. Okay, go back. Let's see if it refreshed it. Okay, yeah, it did. All right, so the upper knob decrease, that's what I want. Okay, there we go. Upper knob increase. So, and there's a push button on that. So that is what I want. So we can demonstrate that now. So let's go in here. So if I was to go into, for example, I wanted to go to direct to, and then I start, if the lower knob, so this allows me now to change. So let's say I wanted to put in MBJ, and I can switch over to MBJ. Yeah, this is amazing. Oh man, look at that. Oh, yep. Yep. And I can hit direct to, so I can hit enter now. So if I hit enter and enter again. Oh, MBJ. Okay, does not exist. Oh, I thought, okay, let's go ahead. Oops. Let's go back over here. MBJ does not exist. Okay. So let's go over real quick. I don't know why MBJ doesn't exist. I thought that was a... Man, I'm loving this. Unless I have to put the K first. That might be the reason why. Yeah, so MKJS. Okay, yeah. So that's my fault. So let's put MKJS. Okay, but you see I'm using this now to control exactly what I wanted. And I can easily and I want S. Bingo. That is it. And now if I hit enter, activate it, it gives me that direct flat. So that is exactly what I wanted this to do. This is the first time actually configuring this portion. So this is very exciting for me. So, so this is ultimately what I wanted to have done with this. So there's so much functionality for this. So I built this from scratch. So using the development board again. Okay, so after figuring out the proper assignments, I was able to also match up the configuration for the knobs. If you can, so if you look on your screen, you can see for these knobs, the top knob I was able to assign to this knob here on the, you can see the camera, and this lower knob I was able to assign to here. So this will control the frequencies. So if I wanted to control the frequency, you can see controls the frequency there. And go back there, and I'm changing the nav frequency, the whole numbers. So I get back up, and if you look over on the right hand side, on the comp side, I reassigned that to this top, and then the bottom knob to the second encoder channel. So as if I turn the top, you can see the frequencies changing. Let's go up to 50. And then the whole number frequency I can change here as well. So additionally, I'm able to switch the, if you look at the come button, the top right, to switch between these, I can now, with this button, I can switch. I think that's the one. Oh, no, that's to the nav. Sorry. So I switch the nav. So with the nav, I can switch between. And if you look over to the left-hand side for the nav, yep, for this nav button, yep, on the left-hand side, I can switch between them easily. So now this is way much better flying. So on the comm I can switch, and the nav I can easily switch as well. So that is pretty cool. Oh man, so much so much easier. And I'll show you over on the right hand side. Now earlier I went over the direct to, and I showed you how I assigned that, and the menu button comes up, so direct to, and then if I hit enter, it will activate it. It's already activated. The flight plan button, that works to clear, and you can see the menu button also, and the procedure. All these are working. I'm so excited. Then also on this side, I did the, yep, this is for the FMS knob. I can change the menu just by turning, yep, and the root also, I can change the tabs in here. Of course, that was daylight, comparing night and day compared to what I used to have to do with the mouse in order to do that. So now if I want to switch a frequency, it's as easy as that. Just like that, I can switch the nav frequency. If I want to switch the COM frequency, it's just like that. It goes quite easily. So yeah, thank you very much, and I'll continue on with making more videos to show you how I designed this and the functionality behind it. All right, thank you so much. Go and support the Montanari, at least to look at his article. That was he's an ST employee, and he basically gave the example for the basic custom HID class using the 32F0 series microcontroller, and I'm using the STM32 H723, so microcontroller. So with that, now there's so much more that I wanted to go over, but I don't want to take too much time, and I'm going to end it right here. But please, thank you very much. Please support us. This is an ongoing project. I'll be doing a lot more when it comes to PID and HID. And in the next videos coming up, I'll go over more of the technical configuration of how to get your microcontroller set up. You have remember, you have the link for the Amazon where the board I'm using. So if you want to use that exact board, that's fine. I'll go over more details on how to configure it with the ST configuration tool. So ST has a STM32 Cube MX tool. You can use that to configure your microcontroller, but again, I'll go over that in the next video. So thank you again, and I really appreciate your support. Thank you.